Please repeat. Guys, the last part, what do you mean by last part? False positive rate, true positive rate. X label is true positive rate. Y X label is false positive rate. Shantanu, guys, what I just repeated? I don't even remember. Shantanu, what are you talking about? Before plotting, indexes 0 to 1, 0 to 1. The threshold, it gives you threshold as output as well. Threshold of each and every value. If you want to see how it looks like, see this. FPR is looking like this is FPR of train. Okay. I think it gives you only again 0.8. Okay. Yes. See this threshold of train. This one is infinity. What is this infinity? Let's give me a second. Okay. It gives you a weird output. That's why I was not using this one. Let's read about threshold. Decreasing threshold on the decision function used to compute FPR and TPR, the first threshold. Okay, you can see the first threshold that they set is np.infinite. Infinite means the larger threshold, the higher number. The higher number, the threshold is going to be the FPR and TPR is going to be 0 and comma 0. Yes or no? Guys, this is what we just calculated. Threshold of infinity, okay, the higher number is going to be 0, 0. Then they mention a threshold of 1. Okay, I'm not sure how they got the threshold of 1. What is this 1? Then they calculated a threshold of 0. Okay, so we need to check how this function is created. Let's see. Where is that value? Yes, it is on decreasing order starting from np.infinite. Always predict a negative class. This is meant for the negative class, but we are not sure when they set a threshold of 1, how we are getting a value like this. Okay, maybe when the threshold was 1, there might be a possibility that we have some good cases. Okay, that's why it is getting us answer like this one. So how many values it is plotting? 1, 2, 3. It is only giving us plot for 3 conditions. This is infinity, this is that 1, and this is again for threshold of 0. Okay, higher threshold will decrease TPR. Yes, higher threshold will decrease TPR. The lower the threshold, the higher we will get the TPR and FPR. So this is the TPR which we are getting. Okay, so we are able to see that for the false positive rate in the training is lower, but in the testing it is little higher. Can you guys tell me why this is the case? Everyone, can you tell me why this is the case, that the FPR is lower as compared to test? Give me interview question for all of you. Correct, Sridhar. Sridhar is correct. About others, guys, this is the interview question. In this particular case, why we are seeing a higher FPR in test as compared to train? Only Sridhar has answered a correct answer. Only Sridhar has correct answer. Others? Ashwani is correct. Alok, not sure what does that mean. You can say so, but the answer is not because of that. Correct, Malikarjun. Model makes more FP on unseen data. Shantanu, that should not be the answer. Guys, the direct answer is we should not even think about it, because train has more data points. It is able to, and it is training on that data. It is learning that data itself. That's why it is having lower FPR. But when we talk about test set, it has The test set data is not a part of training data and it is low in nature, right? It is having less number of rows and it might be a possibility that they will have more uniques. That's why it is little higher as compared to the training set. Are we clear? Is everyone clear how to answer things like this? Okay. There is one other thing which we can plot here in the answer. Where is the answer? This function where instead of now I will talk about, and guys, I'm giving you dinner break. This will end this topic. We have already covered it. Now I want to import ROC AUC curve, ROC AUC score. Okay. This will give us AUC score from the ROC. We can just use it here. Very simple. So I will just use something like this is ROC AUC score. We just need to use this method and then pass y true and y prediction. And that's how we calculate AUC score. So if I want to compute it, it is not defined because I think I need to run it. See this? Now we are getting, this is for test, this is for train. For AUC ROC score, we are getting 0.73, we are getting 0.69. Again, everyone knows why we are getting a lower AUC score in terms of test set. Yes. Yes, Nomesh. That is again a different case. FPR can be small when it is able to answer correctly. Okay. So we have also, yes, because less data compared to a training set. Yes. Okay. The fit on the model, the differentiating factor on the model will be higher. So the AUC score will be higher on the training set. It will have little less fit on the training set when it is an ideal model. So this is still an ideal model, even though the score is not 1, but when we see the model is not overfitted. So this is one of the score. Okay. So guys, lot of the people still, when people learn about AI, generative AI, NLP and other things, they don't know what ROC curve is. They don't know what AUC curve is. Now you have completed a very important scoring part and it is very important for interview point as well. Okay. So congratulations. We implementing things is very simple, but understanding things from the very level is harder to understand. Okay. So we have utilized around our 1.5 hour only for ROC and AUC curve. This part is simple. Then I will start the K nearest neighbor. Okay. So guys, now it's lunch time. You guys, dinner time, lunch, dinner, whatever you guys want to call it. I want to have it. Why it is not saving? Oh God. Cross validation. Yes, I will talk about cross validation after the break. Guys, PDF, there is something wrong with this software right now. So I don't want to close it. I want to keep as it is. So we'll share after once the software is working. Okay. Let me start the timer. I don't want to mess with up. Timer 20 minutes. I will see you guys after break. Are we going to get notes or we should create while watching? Keshav, ideally you should create your own notes because you guys want to shorten it. You guys want to add more details because I'm talking in while I'm writing as well. You might want to do those things as well, but you can also do after class. Write on an overview what things you want to remember, then creates a specific note for interview because till today we might have created more than 200 pages of notes. For interview, that is not at all good. For interview, the maximum notes you should have is 5-6 pages. The overview part. Okay. The algorithm understanding part should be separate. Random forest included in decision trees. Yes. Joshi. Tree is a type of algorithm. Random forest is one of them. Let me share the screen and I'm starting a timer. Okay. See you after break, guys. Till then, let me check what is also wrong with this one. Oh, really? A very great thing to hear, Vivek. Nice. Thanks for letting me know. Nice. Okay, guys. See you after break. Bye bye. Hello guys, are we back? Mm, I think this software is broken, guys. Very weird. Let's see. Oh, it loaded. Not everything. We were only able to load till this part. Okay, this is good. This is good. Let me quickly save it. Wait. 12, 10, 2025. Done. It is not even closing. Guys, I'm just asking you generally, which other course do you guys think you want to learn? We already have a lot of courses. We already have NLP and CV, but a new batch are not launched yet. But Agentic and RAG course are the new ones. But apart from those, Agentic is already going. I'm just trying to understand what you guys might need in future. Agentic AI and Gen AI. All right. Others, just a feedback from everyone. I just want feedback. DevOps. DevOps is not a part of AI, so there is very less chance to get this course from Krishna Academy. Maybe you can search from other places, but the main point of Krishna Academy is everything related to AI. MLOps. We already have a LLM Ops course, so I think that will help you. But we don't have a separate ML Ops course. ML Ops course, Chris has already created a good Udemy video. Fully ML engineer course. Ravi, this is full ML engineer course. This ultimate data science is, guys, nothing but full end-to-end machine learning engineer course. Plus more. Task of ML engineer now previously was still machine learning, but now the whole thing is changed. Guys, AI engineer is what we are doing right now, but there are levels to it. Only project AI ML project for every topic. Okay. I can see a lot of the people are talking about agentic AI and ops. Kubernetes development. Kubernetes development is not a course. It's a part of DevOps. DSA, again, DSA is different thing, guys. Full stack AI engineer. This is full stack AI. Ashish, you have enrolled in full stack. Okay, you have enrolled in full stack. See, guys, if you talk about AI engineer is someone who can do machine learning, deep learning, computer vision, and can create software. Software in the terms of Python programming, coding Python, APIs. So this course has everything except that API part, which is not too hard. If you understand an API, it is not too hard. You can probably learn API within 3 to 4 days. Okay, but I cannot say you will be master of that. But you are already a full stack AI engineer is someone who can do things. There is no course for that. Is it necessary to learn deep learning to get a guys check AI? When we talk about LLMs and others, those are components of deep learning. That's great. That's great, guys. Okay, so can we get started? Everyone, can we start the class now? Yes. Okay, great. Guys, are you excited or not? Today is the very first time I felt that you guys are sleeping. Ashish, quantum computing and other things are fine, but in business is a separate thing. Research is a separate thing. In business, if you say no one is using quantum computing to predict your machine learning or deep learning, it is not made for that. It is for research purpose. Okay. The next topic. Everyone, focus. Now I'm starting. Cross validation. Okay. One very important topic. Again, everything which we are learning from past few days, everything in machine learning. is a interview question. Okay. So let's talk about cross validation. First, I will talk about the problem statement of what exactly, why do we require a cross validation and what is the issue in the current system. So this is our data. Everyone, this is our data, and we split the data into multiple sets. Generally, if I want to split into two sets, I will be splitting into train and test set, right? I will be splitting into train and test set. And then my model performance is based on, I will fit the model from here. And then I will use my test set to evaluate the model. Yes, this is what we do now. Everyone, this is what we do now. But the problem is, maybe our test set is too hard. When the test set is too hard, we will see a drop in accuracy of test set. Train set will be good. There can be another possibility that maybe it is not out, it is our. Maybe our test set is, what can be the other case? Too easy. When it is too easy, then we will get a higher accuracy in test set as compared to the training set. Yes. So we want to reduce this dependency on just a single test set, because out of those random chance, it can be possible that even if our model training, model performance is like 50%, our test can be 90% as well. Again, totally due to the random chance of data that we got in the test set. Or another case is, in the training set, model performed 90% accuracy, or let's suppose 99% accuracy. But because the test set can be too hard or can be out of distribution, we can get a totally different answer, let's suppose 50% accuracy. Yes, because the split is too different. So that is the problem we have currently in our normal train versus test set. Okay, so what we want to do, we want to reduce this dependency on data split and create a new kind of a split. Okay, so now I will be talking about the idea behind cross validation. So the solution is instead of one fixed split, okay, instead of one fixed split, we train multiple times each time with a different split. And don't worry, whatever questions you have, I'm going to answer. I already have answers for those. But first, I will introduce you the problem, solution, and why it is used, when to use, when to not use. Okay, the solution is, instead of one fixed split, we train multiple times, each time with a different split. Okay, now let's understand it, then I will answer more questions. So let's suppose this is our data, this is our index, our pandas index or our index. It can be our index in the CSV file or any kind of file. Then we have data. This is index 1, index 2, index 3, index 4, index 5, index 6. Data is again A, B, C, D, E, F. All right. Now there is some parameter which we need to set in cross validation. And here I'm saying I want threefold cross validation. So when we talk about cross validation, the parameter which we use is how many folds of data which we want. Is this part clear how we set the parameter in cross validation? How many sets of fold we want to create for the data? Is this part clear? Now I will show you what those fold means. Everyone? Okay. Main point of cross validation is this: whatever number of folds we have, each data each data becomes test data once. Okay, each data becomes test data once. If we have 1 million data, then each data will be present in test data once. Okay, so this is very computationally expensive when we have a lot of data, and the use case is little different. I will talk about why we even have cross validation. So let's see fold number one. Here I will write fold. Here I will write what are the data points out of this A, B, C, D, E is going to be in the train set. What are those data points will be present in the test set. So let's talk about fold one. We want three different train test split. In fold one, I am considering, for example, data point C, D, E, F. Okay. Data point C, D, E, F. In the test set, I am considering A and B. Does it cover the whole data? Does this cover the whole data? Yes or no? We only have 6 data points. A, B, C, D, E. This is also A, B, C, D, E. Guys, there is someone again renamed their name to Krish Nayak. Don't do that, okay? It's fine, but that's what I thought that Krish sir is replying. Krish Nayak, yes, okay. It's fine, don't worry. Next is, this is fold number one. We covered the whole data, one set is done. Another set. This time in the test set, we have A and B. Next time, we will pick a different set. A, B, E, F. Here, C and D. Was C and D previously a part of test set? Was C and D previously a part of test set? Ever? No. Fold number 3, we have only mentioned that we want 3-fold of cross-validation data. This time it will be A, B, C, D. Here we will have E, F. Were we able to cover all the data points within 3 folds? Okay. Now see this. What we will do with the fold one, we will train a machine learning model. Okay, we will do ml.fit and then we will get the matrix. Everyone knows what is matrix? Everyone know what is matrix? Yes. We will do ml fit on the second train and test. And again, we will get its own matrix. We will again do matrix, matrics, not matrix. Guys, what are matrices? What are the metrics in terms of model? CS. Matrices, metrics of a particular model means accuracy is one of the evaluation metrics. F1 score is one of the evaluation metrics. ROC, AUC score is one of the evaluation metrics. Yes. Precision, recall, these are called as metrics. Guys, no one is, only few people are ready for interview. What I'm doing. Okay. For each model, we will get its own matrices. All of them will be different. Now, let's suppose we are not even using cross validation. Our model fold one can be one of the case. Yes or no? I'm not using cross validation. Can this be a reality of my 80 to 20 split, 90 to 10 split? Yes or no? This will be the case when I don't use cross validation. I will only have one single train test split. Let's suppose on fold one, I got accuracy of 96%. That was my reality before when I was not using my cross validation. But now because we have 3 folds and every time a different test set is coming, all the data point is going into test set. On second number, I am getting 84%. On third fold, I am getting, let's suppose, 90%. To understand how my model behaves on an overall data, I will take average of it. and average will give me an overall idea that in the real world, because in the real world, this is also a possibility that I have this data, my model might never see A and B. What is the performance? In a real world, my model might be trained on some data and it might never see a different kind of a data. What is my performance? So this particular cross validation folds which we have, it gives us a average of my model performance over multiple folds. We can go all the way till 10 folds, 100 folds as well, totally up to us what we want to do. So this will, guys, what is the use of this? This is not even used to understand our bias and variance. Yes, it is used to understand model bias and variance, but it will not help us improve the model. Not for model improvement. It does not directly help us improve the model performance, but it tells us the real world answer, the real world matrix of what my model performance is going to be in the real world. Are we clear? So this will help us detect what? It will also help us detect overfitting. In this case, it is 96%. In fourth fold, we might get 50%. All the others are around 50. Then we will know that model is overfitted on C, D, E, F, whatever training set was. Model was not able to understand all the features, but in other cases, I have less. So I will have accuracy metrics of all of these folds separately, which I can use. So cross validation is going to use each data point will become test data once they will use it internally. It's a Python thing. Okay. It's a complex part. It is not a machine learning, but this is what we use. As everyone know, in statistics, we use some kind of a test, right? How many of you remember hypothesis test? What was the main point of hypothesis test? That this randomness which we are saying is not due to by some random chance. Yes or no? Yes or no? So same thing when we even do machine learning, why we are even focusing on just a single train test split to tell the model that this is the accuracy we are getting. We should always think like a statistician. Okay. So there are different things. The one which we have learned is called as k-fold. Okay. This one splits data into k parts. Okay. This one splits data into k parts. Each one's, okay, each used once for testing. Similarly, you can think of that as like a brother of k-fold that we call it as stratified k-fold. How many of you know this stratified example I have shown you yesterday? Stratified. In stratified, what we do? We ensure each class is balanced in train and test. But when I apply stratified and k-fold, then I can merge it, yes or no? Stratifies was to split my data set equally in train and test. It should be present 20% and 80% accordingly. When I apply stratified and with k-fold, then it will ensure class balance in each fold. Are we clear? Guys, class balance is different than k-fold. K-fold does not have to, k-fold has to do nothing with class balance. Did I mention that C, D, E, and F belongs to some class, A, B, C, some belongs to some other class? No. This one is just random splitting of data, but the next time it will make sure that in each test we will have, in each test set data, it is going to be repeated in multiple k-folds. It will do the split internally. But stratified meaning itself is different. Stratified ensures that class balance in a split of data. And in k-fold, we have multiple folds of data. So it is going to ensure over multiple folds as well. Is everyone clear? So we are going to see k-fold when we are going to apply some algorithm, but no, I don't want to do k-fold right now. It will do things internally. Yes, just like stratified, we just mentioned stratified equals to true. It did the stratified splitting of data internally. We don't have to calculate it. It will do internally. The Python function is made for that. And that is what cross validation does. So guys, this is again a production level thing which I'm talking about, real world. Okay. This is how we do machine learning. Every time I will add a little bit of detail of real world machine learning, which I was not telling you before. Let's suppose we have data of 1,000 rows. This is what we got from our data engineering team. Our manager gave this data. Next thing is we are going to take this data and then do what? Guys, what is the next step we do after data? What is the next step which we do after this one? We perform EDA. After EDA, guys, why you are saying split? When we are going to do EDA then? EDA, after that, we are going to do feature engineering. In feature engineering itself, we can do feature selection. So it is again a good step, but feature selection is a part of feature engineering itself. So I'm not going to complicate it, but Smith, I'm glad that you remember it, that we also do feature selection. Okay. Once we have that, then what we are going to do, we are going to prepare, this data is already prepared for model training. We are going to do train, test, split. Or can we do better? Can we do better? We can create cross validation split. Yes, we can use either stratified or k-fold. We can try both of them. It's totally fine. Then using cross validation, first of all, we'll train the model. This will create multiple models, right? This will provide us, cross validation split will provide us which model we have to use or what is our actual model. It does not provide us which model to use, but it will give us an overall accuracy of the model. Yes, it will give us in general sense what is going to be my model accuracy. But it is only for, let me just write, it is only going to give you general accuracy. So this is only to know my model performance. But from where we are going to get the model? From where we are going to get the model, the actual model? Even though we can create 100 models for here, from here, but do we deploy all the 100 models or only one? Do we deploy all the 100 models or only one? We only deploy only one model. So cross validation split, we only need to know to understand how my model performance is going to be on the real world. That's the main use of cross validation split. Okay. And then using train test split, then again, we can use ROC curve and others to define my model. Okay. What threshold I will be using in logistic regression, but that is again, our algorithm based technique. But usually from train test split, we will get a machine learning algorithm. Okay. Machine learning algorithm. But this part, I want to introduce it after cross validation. Now see why I am saying that. Focus here. Once we understand a general accuracy, then what I'm going to do, because I already know my general accuracy on train set, my general accuracy on test set. Yes or no? Yes or no? My general accuracy on train set, my general accuracy on test set, I will be able to know from here. Now that I know my model performance, I don't need to prove that my model is bad or good. If my model is performing bad, I will not even go and train the final algorithm. I will again go to feature engineering or EDA and again come back to cross validation and keep on changing it until unless I'm satisfied. Yes. No, Alok, it will not leak anything. It will be different. This outputs you will get for different model. Train for model number 1, train for model number 2, train for model number 3. For each model, train and test split, it will have its own train. It will test on its own train. This part is done. Model 2 will again start from some scratch. Nothing is dependent on each other. Every part is a new instance. Hello, are we clear? Okay. So everyone, we are going to create train test split again. If you're not if you're not satisfied with the test set, everyone, do we need cross validation? If you have enough data, yes, Aruna, we need cross validation. Even if you do 2 folds, do 3 folds, it's totally fine, but not always compulsory. You can again choose it. The more you do, the better you know more about your model. So for each of this cross validation, we will get test set of model 1, 2, 3. We will get the answers. We are not satisfied. We will again do EDA, feature engineering, trying to check what features we are missing and do it. It might be possible where we will not get a good accuracy because our data itself is bad. It happens every time. If our data itself is bad, we cannot improve the model. But once we are satisfied, we know what EDA and feature engineering gives us a good test result. Is everyone able to understand? Once we are satisfied, it means we have a set of EDA and feature engineering which gives us good results. Then here what we are going to do, we are going to create our model on train plus test data. At final, we are going to create our model on train plus test data for deployment. Why? Because if training contains 1000 rows, test contained 300 rows, previously we've already tested what my model performance is. Do we need to lose 300 data just to create a separate test set? We have already confirmed it works. Once we confirm that it works on test set, in the deployment, are we going to use this test set, or are users going to use this deployment product? Who is going to use this deployment? Our test set or users? Tell me, everyone, who is going to use our deployed product? Our test set or users? Our users are going to use it. If our users are going to use it, why to waste this 300? Why not include in a part of train and test so that our model is more robust as before? So in the deployment, what we want our model to as strong as possible. But we have already calculated the users will now create a new test set. Whatever data user is using on, that will be the new test set. And we will have a general idea from the cross validation split what might be happening, because we have already giving us only a few part of data in the test and train. Second time a different data on test and train. So we have a general idea of how the performance looks like. So this is the part which we have learned, that in the deployment, once we are satisfied from the cross validation, then we will add both the data set for the model deployment, because there is nothing like data leakage or anything. It is deployment. That's it. Are we clear? We have already tested it. Now it's time to deploy. Okay. We will test on real world now. And whatever, if this guys, this is how it happens in real world. Whatever user data user is using our deployed product, right? User is using some set of data. We will keep on storing user data into the database. From the database for the model version 2, we will take this data, our previous train and test, we will take our new test set and then start doing this whole thing again. So this creates more data. Version 2 will have more data, more from the real world, more from the previous set. So so the model has seen the entire universe. How Shiv model has seen this data? Can you predict that model will? Shiv, first of all, I will request you to please revise all of this again. What I said. These model used in model selection in sklearn library. Ravi, model is what? Everyone, what actually is a model? Tell me. What actually is a model? Model is nothing but a class which contains lot of methods, and those methods uses what? M1, M2, M3, M4. If you know these weights and if you know the actual formula, you can create your own model. Model is nothing but an object of a particular class which contains method. When this object, when model is nothing but a variable which is an object of sklearn, linear regression or logistic regression, and if it is the object, all of them has a predict method. Yes or no? Yes or no? That is what a model is. Are we clear? KK, tell me how the features are going to change in the real data. Or are you saying if the distribution is going to change in the real data? What are you saying? Features will not change. Distribution might change. How the data looks like, the trend of the data might change. It changes over time. But features will not change because we are the one who has deployed it. Guys, in the Facebook, we have first name, last name, and others. Whatever data they were collecting, their forms remains the same. They collect every time the same data or a new data. Even if a new feature is added onto the front end, we as a machine learning engineers, do we need to use this feature if our model is made on this five? If our model is made on five features, do we need to use two more features now? No. Our model works perfectly fine with these five features. Is everyone able to understand? Guys, really, today you guys are all sleeping. I don't feel like teaching. What is happening? The class is not at all complicated. In supervised learning, cross validation is very expensive. See, guys, it is expensive. We don't really do cross validation every time. As I mentioned, if you want to get all the clarity, then do cross validation. Otherwise, it will be an expensive thing. Okay. Is everyone clear on what actually is cross validation split? Is everyone clear what actually is cross validation split? Done. Okay, that's great. So guys, so far, did you enjoy the class? Because next week is going to be weekend. And then the SVM I'm going to teach, it is going to be very, very, very complicated in term because there are a lot of mathematics. It depends what kind of model we are developing, domain specific or generic model, cost is relative. All of that is true. Cost is relative based on not on domain also, but on how should I say? Testing might be relative based on the domain where we want more clarity, but model is dependent on the number of features and only number of features. And computation is by using for training that model, how many number of rows and features are also there. Number of rows is the main thing. No, Nomesh, k-fold is a parameter of k-fold is a parameter of how many times you want to fold the data. I told you this is the original data. We folded 3 times, and this is the technique we used. Technique is cross validation. When we reporting give average with standard deviation, when we are doing cross validation, Aruna, I don't understand. Are you saying or are you asking? Yes, the more information if you can provide, the better it is. But make sure that your manager understands standard deviation and other parts, because they are going to take the final answer whether the model is good or not. No one is going to ask the standard deviation of the model if the manager is not too technical. Otherwise, they will ask, "It is up to you. Tell me model is good or not." But you are right that more information is good. We don't need to use k fold every time. No, guys, we don't need to use k fold every time. It is one of the method which we use to understand more about the model and to understand how the model performance is going to be. Okay, clear? So done. So let me give you guys some time. Not sure whether you guys are in the mood to learn new things. Now tell me, do you want me to teach more stuff? Do you want me to teach next week? What is going on? Continue more next week. Next week. Whereas the class was not even complex. No, guys, I'm not teaching SVM. If I was teaching SVM, then we require more 5 hours. Pankaj already said bye. Pankaj, where are you going at night? I just want to know. In every class, you want to go early. Do you want to have some tea, coffee at night? Where are you going? Great, Vijay. I am. It's really good that you are doing everything. See, Vijay is saying, okay, I will not say anything, but there are a lot of people that KK, that is not the answer. Maybe that is the answer. But there are a lot of people who is still attending, even though they are like their world is not easy. Still, they are attending. They have a lot of things to do. Okay, guys, let's at least do a main concept of what k nearest neighbor is. It is not even at all mathematical. Are we clear? It is not at all mathematical. It is very, very, as I mentioned, it is the simplest of all algorithm that we have. And Vijay, thank you very much for joining. If you want to go somewhere, please feel free to drop off, okay? But thank you for attending. Okay. Everyone focus now. I'm going to the next part. It is the simplest algorithm. If you understand it, you will feel like it is not even a part of machine learning. That's how a lot of people also feel because it is very simple. So now I will talk about algorithm. Okay, that's great, Vijay. KNN. Okay, the full form of KNN is K nearest neighbor. Okay, now I will talk about why does it even exist? Why do we even need a KNN algorithm? First of all, I will talk about KNN algorithm can be used for classification as well as regression. Mallikarjun, that cross validation I will talk about it when we will do KNN. I will use it with algorithm itself. Are we clear? No, guys, we should not use KNN in the first class because the first class we always start with what actually is machine learning. If I go with this with machine learning, we will not have a sense of what is machine learning. So it is used for both classification as well as regression, but you will see most of the use cases we are getting it in classification. Okay, guys, did we use KNN anywhere? I have shown you KNN before. We have used KNN as one of the imputation techniques, correct, Smith and others. We have already used KNN for the imputation. Now we will understand how that was working. KNN is a part of machine learning. Okay. So why KNN exists? Because if we talk about logistic regression and SVM, those uses mathematical equation. Those uses mathematical equation. That is what those equation means, either equation of a line or a equation of a curve. Yes, that is what we use in logistic regression, linear regression, or SVM, which we are going to learn in the next class. Okay, and it's not like we always have to use that mathematical equation to use something. What if let me just write, what if data doesn't form a nice line? What if your data looks like this? Now, do you think can we fit a single line to differentiate all of this data? Everyone, can we fit a single line to differentiate all of this data? No. So the main problem statement was, what if our data does not form a nice line? It is scattered irregularly. And also, the previous algorithms like SVM and others uses line or curve. And if line and curve cannot be used, then we cannot use those algorithms to solve our use case. So now we require a different algorithm. Okay, that is different algorithm. So what we do here is that instead of relying on solution, instead on relying on equation. Okay, this is what KNN says. Instead of relying on equation, why not use the data itself to make decision? Okay, why not use data itself to make decision itself? And that is what KNN is going to work. KNN does not compute because it does not have any equation. In KNN, we don't compute any parameters. We don't compute any parameters. Everyone know what are parameters? There are no learning parameters here. Okay, the data itself is the majority one. No, Joshi. No, we don't create clusters here. Just neighbors. Those are K means clustering. Okay, we don't compute any parameters like M1, M2. We don't compute any beta. We don't compute any M or something. There are no such thing present here. It is very, very, very simple. Okay, and solution is KNN. And also this one is called as lazy learner. It is lazy because it does not learn any equation. Because it learn any equation. Okay, it uses data for its intelligence. Are we clear? Is everyone clear? Sir, is it recommended for multi-class classification? Guys, this is a powerful yet a very simple algorithm. It is used in the industry. Okay, it is used in the industry. Okay, now I'm giving you guys this example, same data. Now tell me, I am giving it a new data point. This data which I pointed, this should be a part of which color? This should be a part of which color? White. It should be a part of which color out of these different colors? From my point of view, it should be a part of orange. Why? Tell me your deduction of why. Why do you think it should be orange? It is near to this orange, whatever this orange is. It is near to that cluster of orange groups or groups of orange. Yes. Now let's say I want to talk about a new data point. So this one we have already concluded it as orange. So I filled it as orange. Next, tell me about this point. Tell me about this point. This point is okay, yellow. Okay, we are saying yellow because it is closer to the yellow. Okay, now we will learn k-means clustering in a single go. Currently, we are currently working with k equals to 1. We are checking this data and we are checking if any of the data point is closer towards that value or not. When we are only utilizing one data point to check it is closer or not, this is called as k equals to 1. We are categorizing a new data based on only one neighbor. Are we clear? Are we clear? No, Vivek. K-means clustering and KNN are not at all same. Okay. And for this particular white point, when the K is equals to 1, then we are saying it as a yellow. Now for this particular point, tell me when I want to confirm it more using three neighbors, total three neighbors, tell me what should be the answer? What should be the answer? Orange. For this point, it will be orange because for this point, yellow was the one neighbor. For this point, there are two orange neighbors. Yes or no? There are two orange neighbor, but only one yellow neighbor. And based on what should we do now? Based on majority. Based on majority, this new data point when the k is equals to 3 will be assigned to orange. But it will be orange when the k is equals to, it will be orange only when the k is equals to 3. When the k is equals to 1, it will be assigned to yellow. It will be assigned to yellow. For k equals to 2, we will check the distance. That is a different thing, Shiv. I will talk about it. Okay. It will be assigned to a yellow. So k means clustering. The k in k means clustering is nothing but total number of neighbors that we have written. K nearest neighbors. K is nothing but a variable. How many nearest neighbors? How many nearest neighbors? Is everyone clear what do we mean by K? K is the value. It defines how many number of neighbors we are using to define a particular new data point so that we can categorize it. Anand will talk about it. That is weighted K nearest neighbor. Okay, Anand? All right. So this check happens for every user input during production. We do not have any model. Yes. That model itself is going to have all of these numbers for calculation. Nomesh, we do have a model for production, but model itself uses all of these data points internally. Okay. We don't have a clustering. When the data points is 1 million or something, we don't have this kind of a pattern. We use a different model which understands pattern. So, but this one is lazy learner, easy for small use cases. It can also be used for large use case. See guys, if this is the same pattern which we are able to see in 1 million data, do we need to have 1 million data, all the data to be stored if all the patterns looks like this? No. There are some other algorithms which will help us to understand better, but not now. Okay. And this is what k-means clustering is. So in k-means clustering, we define the value of k. the value of k is mostly chosen as k should be chosen as a odd number. You can obviously use a even number, but when we choose a odd, then we can have a majority. Yes or no? When we have a even number, then majority can again be, we cannot pick a, if we have two different dots, we have one data, how can we pick a majority wins? To have a majority, we require a odd number. So always try to have an odd number in k means clustering. So k should be, not should be, k should be taken from the odd numbers, but you can obviously pick even numbers as well. So k is a number which we can pick from the odd. So the steps, let me conclude all the steps. Okay. First we have, let me write the algorithm, everyone. Okay, let me write the full algorithm now. But okay, before that, this is an overview. What we usually do is, let me copy this whole thing and will show you what actually happens and how it defines the neighbors and other parts. This is a new data. This is a new data. Okay, let's say all the data points here are 1, 2, 3, 4, 5, or let me reduce the complexity. Okay, I'm reducing the complexity. We're reducing the complexity just for some calculation. Looks good? Yes. So let me name few of these values as A, B, C, D, E, F, G, H, I, J, K, L, M. This new value which we got is, I'm going to say it as X. Okay. Are we clear? So we have lot of different points. We have lot of different points. Now I'm talking about the actual algorithm itself. We have point. We have all of them coordinates. Yes, we will have their coordinates in x and y axis. Yes or no? And also KNN is a supervised algorithm. Supervised means we are going to have ground truth in the data. So we already know A belongs to the blue, B belongs to the blue, and some coordinates of it. Yes, feature and target. Okay. Then I'm going to write the formula. I will talk about what this formula is. Then we have distance. Everyone, now see this. So for point A, we will have some coordinate. I'm just giving an example. Let's say the coordinate of point A is, this is 1, this is 1, this is 2. 1, 1, 2, this is 2, this is 3. For an example, point A coordinate is 1, comma 2. Okay. Now, what value we need to find? We need to find the group of, what variable? We need to find the group of, tell me fast. We need to find the group of x. What is the coordinate of x? It is somewhere around, 2, comma 1. Yes. So what we do is, in k nearest neighbor, from this point we calculate point of each and every point in my data set. We calculate the distance of each and every data point exists in my data set. Is this part clear? The formula which we use to calculate the distance of each and every data point is, let me write that formula. There are different kinds of formulas which we use. Okay. This one is root of xi minus xj square. This is how we calculate the distance. Okay, root of xi minus xj plus other factors. Let me give you some other factors as well. Yes. It is summation. Formula is summation of xi minus xj square. Guys, it is not expensive. See this. So first of all, our x distance is 2, 1. Our point A distance is 1, 2. So if I talk about what are x1 and x2, this one is going to be our x1, this one is going to be our x2. So we are going to do, everyone see this formula. This is how we write it. Within root, I am going to use this formula and I will write 2 minus 1 square, 2 minus 1 square plus, because it's a summation, now I will do 1 minus 2 square. 1 minus 2 square. Can someone please calculate this for me? Can someone please calculate this for me? No, final answer, not in root. Final answer, not in terms of root. I will say distance from 2, 1. It means for point x. Shiv mentioned 1.41, 1.41. Similarly, we will calculate for point B. Point B is, let's suppose point B is 0.9, 1.7. Now we will use this coordinate and again calculate distance from 2, 1. 2, 1 is what? Our x. We will get some other value. Just give an example. Let's suppose we are getting 1. From point C, we will have its coordinate of x and y. We will again use the formula and the answer I will write it here. Let's suppose the answer is here. For point D, I will do the same. Then I will get an answer. So what I'm getting? Distance of point A, point B, point C, point D from the new data point which we want to categorize. Then what we are going to do? We are going to do sort. Are we clear? We are going to sort the values of distance from top to bottom. Sort the distance. Once we sort the distance, then we will get what? Once we sort the distance, then we will get what? If we sort the distance, we will get data points which are closer to, after sorting, we will get data points closer to x. That is our x is nothing but 2, 1. Okay. Then we will use the selected k. Let's suppose k we selected was 5. So we will take from this order, from all the data that we have, we will take only the first 5 and check which category they belong to. Let's suppose out of 5, 3 are saying, orange. And out of 5, 2 are saying yellow. From the majority, what is the new group of x? From the majority, what is the new group of x? Tell me. From the majority, the new group of x is orange. And that's how we classify a new data point in the test set. Everything is test. That's how we classify the new data point from our original data. Are we clear? Are we clear? Okay. And this covers our k nearest neighbor. Very simple. Okay. The formula which we have written, this is called as Euclidean distance. How many of you have seen Euclidean distance in their high school classes? Distance of a point of xi and xj is nothing but root of, then you can use summation of xi minus xj square. Obviously, there will be more parts to it. This is called as Euclidean. There is something called as Manhattan. You can also use Manhattan distance. All we need to do is just calculate our distance. Manhattan says summation of absolute of xi minus xj. This is a Manhattan distance. This is a Euclidean distance. Is everyone clear? Sir, if 2 yellow are nearer than 3 orange, no, always a majority only in terms of number. Say why if we have 3 yellow and 2 orange, why we will select orange? Does it even make sense? Always from the majority we select. Always from the majority. How many of you are able to understand what K nearest neighbor is? How many of you are able to understand that? Which one is by default? By default is Euclidean distance. This is the most common ones. Okay, but distance is distance. Others, how many of you are able to understand this? Very simple. Yes, we will sort the distance in ascending order. We can select the type of distance you can select. It should be present in one of the parameter. Okay. How we find the K? Now I will talk about little bit. It's not really a straight answer. Every technique which you use is kind of giving you a different value of K. But I will give you some hints to it. Guys, see, K nearest neighbor is something which you should check based on your training data, whether you are happy with the answer or not. It is really hard to understand what is the optimal value of K. But I will help you understand. Yes. Okay. This is what you will find a general case. So optimal value of K. Okay. Optimal value of K. So when we use a small k, it usually means that our k value is around 1 or 2. This time we will get high variance. Why we will get high variance? The model reacts too strongly. It might be present of a noise. If we have a data, we have this cluster, but one of its cluster is kind of an outlier or a noise. Then if we have all of different categories of blue, okay, and data comes here, let's say suppose we have a lot of noise. This is yellow category. All of these are yellow. And all of these are white. If a new data comes here, here, and we selected our k is equals to, maybe I need to give a different example. Okay. Our data is present here. Our new data point is present here. If we select a very short k, let's suppose 1. If our k is very small value, then even though it is more closer towards white because of this yellow has outliers, we are going to see that it is a category of yellow. So when we select a very small k, because of the majority or the neighbors, our answer might be reflecting too strongly because of the noise present in the data. Are we clear? Are we clear? Now medium. In medium, I will say the ranges are usually between 5 to 7. You can still pick 9 as well. But there are some other cases when you pick k equals to K goes all the way till n. N means a large number. It can be 50, it can be 100 as well. So when you have a medium number of K values, it is usually balanced, right? It gives you good generalization effect. It is good for it gives you smooth decision boundary of based on the groups that we have. But when we have large number of Ks, the model becomes too general. If we say this data point, this data points, and I want to say a K of 100, it will cover everything. Yes, it will cover everything. And on this everything, whatever the majority is, let's suppose we have male of 100 rows. We have 50 rows of female. When we use k-means clustering, our data falls between them and our k value. Our k value is 100. What is going to be the answer? Because the majority of the data set is present for one of the classes only. So when we select a very large value of k, then we will see high bias. Is everyone clear? What is the issue we are going to have? So optimal value of k is 3, 5, 7, 9. It is also fine. 5 is a good number. 5, 7, 9 you can pick. But again, depends on how many data that you have. All right. Is everyone clear? So obviously, we are going to create train test set and we are going to see which value of k is giving us less error. Then we are going to pick that value of k. Okay. Again, there is no answer from you guys today. I'm looking for a practical use case. KK, do I not teach a practical use case? KK, you have your answer? Obviously, I will. But if I don't teach all of this concept, what we are going to do? Clear so far? That is k-means clustering. Guys, elbow is good. I will show you that elbow, but just a plot. Everything is just a plot, guys. Elbow is a plot which looks like elbow of our hand, and that's what we do there. Yes, look, I will do that. Okay, like Practo. Maybe we can. Or maybe we can use some other things. Okay, should I start with practicals today? It will not take long. It is a very short practical code. Yes? Very simple. Guys, was the topic same? Was tomorrow? Guys, tomorrow there is no class. Tell me, was the topic hard? Topic was very simple. I think within okay, without didn't understand, sir. Pankaj, are you even in the class? Are you even focusing in the class? Because you always want to go out. I thought you were not here. How many of you are not able to understand this? How many of you are not able to understand this? Tell me. Everyone, tell me how many of you are not able to understand. Yes. Yes, Shiv. When the k value is okay. When the k value is 3, we need to check the distance. Shiv, we cannot directly say. Okay, from what I'm guessing, people are able to understand. So, guys, within 10 lines of code or 15 lines of code, it will be only less than 10 cells. I will be able to complete k means cluster, k nearest neighbor, and then the cross validation part I will teach in the next part. Are we clear? Very simple. I will not have any pipeline or anything. No pipelines or anything. I will not download even the data. I have prepared the class like this. See this. This is k nearest or let me just write knn.ipynb. Guys, trust me, it is very simple. Okay. So what I'm going to do I'm not even going to create a data set or go into the Kaggle. In sklearn, we already have a library, we already have a module which has a lot of data sets. Okay, it has a lot of popular data set. One of them is load iris. It is one of the easiest data set which you can use for this one. I will show you how it looks like. But before that, we need to use pandas, because yes, load iris data set. So what I'm going to do next is load data. See this, how easy it is to load data. This is load iris data set. This is about data set. This data set is a classic and very easy multi-class classification. It contains, if I show you, okay, I think the description is not too good here, but it contains information about iris flower, and iris has three particular breed. Okay, iris has three particular breed. I will show you those names. One of those breed is called as setosa. Another breed is called as versicolor, and the final breed is called as virginica. So these breeds are nothing but our target. For each of these breeds, we have features like what is their sepal length in centimeter, what is their sepal width in centimeter, what is their petal length. Everyone knows what is petal. What is their petal length and what is their petal width. So from these four features, we just want to categorize the breed of iris flower into these three categories. Are we clear on this data set? It is a very simple data set. Target column will have three categories, and these are X1, X2, X3, X4. Is everyone clear? Very simple data set about a flower, and we have sepal length, width, petal length, width. Only four things. And we need to just, based on these features, we need to categorize whether it is a setosa, versicolor, or virginica. Very simple. Done. Data loading, data understanding is done. Now I will create an actual copy of the data set, which I will use later in the next class. But this is just creating a copy xdf, because I'm going to change the x. And then I'm storing all the y, because you can see iris data is present in iris.data. That is all the features. All the target is present inside iris.target. So they both have different methods. This using iris.data, I will get features. Using iris.target, I get y. So I'm storing and creating a data frame from x and y values I'm storing into actual. Done. Till this part is everything is clear. This I will use in next class. Are we clear? I'm just storing it into a new data frame, but I'm going to use our x and y which we used. Now let's see how the data set looks like. We have only 150 rows of data and only 4 columns. We only know 4 columns. 1, 2, 3, 4 are the columns. We have 150 rows. That's all we have. And if I do x dot head, this is how it looks like. See, it does not have any y column. If you want to see with y, we can use the data frame which we just created, which we are not going to use. We are going to use in next class. Clear? See, we have index. We have index. And if you want to get the index is also present inside the iris class. We need to use a method called as iris target names. See this? In iris target, we have all the target names. What is the mapping of those target? What do we mean by 0? Is 0 setosa? Is 0 virginica or versicolor? We will get that information from iris.target names. 0 setosa, 1 is versicolor, virginica is this one. If you want to create a dictionary that 0 belongs to setosa or something, we can just create and iterate over it with dictionary comprehension. For I comma name in enumerate of I comma target names, I just want to create index with the name, and this will create a target mapping. Is this part clear now? Guys, same thing, I just converted it to our dictionary. Yes, very simple. Now I'm going to create train test split. Okay, but we need to import train test split. Where we will import train test split? From sklearn.model selection. See how easy it is. I've imported it. And everyone know what is stratify. Test side, I'm keeping it as 20%. I pass X and Y original, which I originally took from iris data and target. I am passing those to create train test split. Done. Now, very simple. I'm going to transform my X train and X test, and I'm going to scale it. So I also need standard scaler. See, as I mentioned, I'm not going to use any pipeline. So I'm importing two more things, standard scaler and k neighbors classifier, k nearest neighbor classifier. So I have imported standard scaler. I'm doing fit transform on X train. Then I'm doing the transform only on test. Okay, so that I can at least test what the performance is. Is this part clear? Is this part clear? Now what I'm going to do, let's define k is equals to 5. Done. Then I'm going to write my k neighbors classifier. I'm passing my total neighbors as equals to 5. It will create an object. Done. Model created, but it is not learned anything. When we do fit, it is going to fit on all the data. So I passed X train scaled and Y train. Model training is done. Now I will be predicting on X train scaled and X test scaled. If you are setting k as y, we need train set. Aruna, what are you saying? If we don't fit on 5, 5 is the number of neighbors to look when you are going to predict. It is going to be set as a parameter. We are not doing any fitting. It is not like we are looking for m1, m2, m3. Internally, it is going to set this 5 as the number of neighbors. As a parameter, it is just going to save it. Are we clear, Aruna? Otherwise, how it is going to know that we need to look for 5 neighbors when in the prediction? Aruna, are we clear? No, against this 5, no, guys. Distance is calculated on all, then sorted by ascending order, then only the top 5 lowest will be selected. Are we clear? But it will be respect to the test data. Those 5 distances will be with respect, those all distances will be with respect to 5. Okay. This is, I am predicting on Y train. Similarly, we can predict on test. And if you guys want to check the accuracy, how can we get accuracy? From sklearn.metrics, we can import the accuracy. And for accuracy, I will just predict how it looks like. See this? %97 accuracy we got in train, 93% accuracy we got in test. And we are done with KNN, but there are a lot of things like cross validation, choosing the right value of K, which I will talk about in the next class. But still, we are able to complete our today's agenda. Guys, is KNN hard? Is KNN hard? Easy? It is very easy. KNN is very easy. If you guys want to see confusion matrix, you can also plot confusion matrix. All. Nomesh, all. Okay, it is going to calculate on all. As I mentioned, we have multiple features, x1, x2, x3, x4, others. It is going to calculate like that. 4 dimension. Because our data is on 4 dimension, we are going to calculate on 4 dimension. The new data that we have, if you don't know what the new data, everyone see this. Now you will understand. I have created this predict method. Everyone knows what is this method. We are going to pass the actual values. We are going to transform. KNN will predict. We will see the answer. Yes, everyone knows how to create this function. Yes, this is the function. Now, if we want to predict new, this is going to be our test set. In this KNN object, we have all the data points. When we pass 5.1, 5.1 we are passing to sepal length. 5.1 minus sepal length of all the data points. 3.5 minus sepal width of all the data points square. We will keep on doing this. Are we able to understand? In the previous example which I showed, we only have two. We were using distance of 2, 1. But now we will be calculating distance of, it will be a 4-dimension. It is not just X and Y. It will be A, B, C, D. And then here we will have other features, different data points. Each data point is on 4-dimension. We will have A, B, C, D. How was I calculating? This is, let's suppose, A dash, B dash, C dash, D dash. A dash minus A square plus B dash minus B square plus C dash minus C square plus D dash minus D square root over it. This is going to be the distance. This will give you a single value. Yes, single value. Then that value we are going to sort it out. Yes, is everyone able to understand how we are going to calculate it? Total number of features is going to be calculated from, because the data also has that many features. So we can calculate the distance. And that's how we calculated the distance. And if I predict it for this particular data, let's see what is the species of this data. Setosa. Are we clear? So in the next class, I will show you the demo of cross validation. Okay, and with the help of cross validation, I will show you how to select the optimal value of K, because we will know what values to select from the K. We will have multiple folds, and I will show you elbow method and few other methods to define this K. But is it working correctly? When I say my K is, let's suppose 13, very high number, but still not too high like 100. See, accuracy increased in the test accuracy. It got increased. Dishank, what function you want me to explain? Guys, how many of you don't understand this function? This is kind of the assignment from past 2 classes. You will not be able to understand this function when you haven't attended the assignment. How many of you are not able to understand this? Tell me. By that, I will know that you guys are not completing assignment. From this data, predict iris. Yes. Apart from one person, how many of you are not able to understand this function? Dishank, can you please it and let me know? Dishank. Others, please read it. And personally, I feel like a lot of you here just attend classes and don't really worry about the depth. I'm only teaching kind of the minority of people who wants to actually learn in depth. I'm not saying to you, Dishank, okay? I'm saying to others. There are a lot of people who attend classes on live, but only I see 10 to 12 people, 10 to 12 people names who frequently ask questions. And statistically speaking, you guys can also derive that how many of you are going to get far from that. Okay. I was once behind the scene person who just want to listen to the class, and once the class is over, my course curriculum is done. I have completed Krishna Academy Ultimate Data Science. I will post on LinkedIn, and my task is done. But the task is already started from the day one. And if lot of you thinks that attending the class is more than fine, then trust me, every 2 months we are seeing a new improvement in AI. And if you are wasting your time here, it means whatever new things are coming, you will also lose there. You're losing on the both ends. The main core concepts, you are lagging behind. And then the newer things are coming, you're not able to understand those. You're also lagging behind. So please don't do those things to yourself. Trust me, AI is very simple to get into, but it is only you who can make it hard if you don't work well enough. Okay. So it can give you, if you get into AI, if you can understand a lot of depths, only you will know in future that a lot of people understands money, right? That I'm learning something so that I can get an increment. I'm learning something so that I can get into a new job. You can only get a flavor of those kind of feeling when you will understand something in depth. And if not depth, then you guys have to answer yourself in few months. Guys, from those data, we are creating a data frame, okay? And I'm passing the column names as well, so that I can create a data frame. Now on this data frame, I am doing the scalar transformation, the scaling. Whatever we did the fit transform on train, now we are doing just the transformation on test. We get a sampled test set. Now knn.predict, I am predicting something. Okay, when I take the 0 index, I will get the answer. Okay, I will get the actual answer. So if you don't want, I will show you how both the answer will look like. Either I will do knn.predict, how it looks like, and with just prediction, that is with 0 index. Just a way, I just want to retrieve that 2D index out. Let's print. It was in a 1D. Now I've extracted and got the value from here. That is nothing. That's why I've written 0. Now that I got the prediction, this prediction is 0. How will I know which class it got predicted? Does users are going to know what is 0? Users are going to know what is 0? No. What is 0? Do we have a mapping of 0? In Irish target names, which is a dictionary, when we pass 0, it will predict us the name, which is Setosa. If not this, you can create your own function, because we have created our own dictionary here. Can we use this dictionary also to update when it is 0, what is the answer? Same dictionary, can we use it to predict target mapping? We can use it. When we pass the index, it will provide us the actual prediction. So I am returning what species this belong to and what is the prediction. The prediction is either 0 or 1. That is this prediction. Is it hard? Is this hard? Guys, this is the simplest of thing. I've covered this, I've covered this, I've covered this, I've covered this. At the end, I just merge all of them in a very simple function which contains 6 lines of code. Okay. So kind of you guys need to improve. We have almost 2 weeks. After around 12 days, we are going to have our next class. What I want you to do is revise everything which we have done. You guys should be able to debug or understand other people code. If you see this, all you need to do is people are creating data frame, doing some transformation, doing predict, and we are getting something out. All you need to understand on a high level overview is this. Once you use it, then try to print something, what it looks like. So you need to be faster in terms of how to understand someone else's code. Okay. So try to practice it by watching the previous class notes, not the recordings. And try to revise as fast as you can. Don't stop too much on a single place and just skim over it. Okay. So by this, I have completed today's agenda. Next class is going to be after a lot of days. We have a big break. And you guys' task is to complete the 2 assignments which I gave, practice few things, watch few recordings from Chris sir's YouTube video, like the agentic AI. What is agentic AI? What is the rack system? Please try to do that. The more you learn, the more you're familiar with this whole AI ecosystem. Otherwise, you will always be stuck in that basic part of it. Everything will become basic after some years. For AI, machine learning has now become the basic part of it. Or obviously, it is very tough, and not every engineer knows what is machine learning in depth, but you guys know that. So please try to practice it. Okay. And I can see almost half of the people has already dropped from this class. So guys, please don't take these things lightly. Next week we don't have this class because of Diwali. We have holidays. Okay. So thank you very much, guys. Guys, we have almost like 2-3x people joined, but now we have around. I paid the fees. I attended agentic and generative AI course and did not complete. I need to attend the second batch and complete the course. I tried to contact support staff once. I did not get answer. Can you please help me to arrange this? Aruna, they will answer because a lot of the people, once they are not able to reach to me, support team did message me that please try to handle that from your batch. So maybe try to, there are two different numbers. Please check with that. And because I don't have your number, email, that will be very weird. Okay. So again, check it. Else connect with me on LinkedIn and I will send your message screenshot to them. Okay. With your number, because how they're going to contact you. So guys, let me share my PDF. Is everyone clear what they have to do? Everyone, are we clear what we have to do? Please don't take these things lightly. Trust me. Slacking off with your future is only you are going to pay for your future. There are people I know who is working very hard in this class. I will guide them for sure. We need more things than hard work, and that is where I will fit in. Okay. Vivek, not next weekend, but next to next weekend, we are going to have class. That is, holiday is on 18th and 19th of October. Other classes are same as it is. And people who are leaving, thank you very much, guys, for joining today's session and wish you very happy Diwali. Wish you festivals. Rahul, depends on where you want to get job into. Everyone, I will also suggest you guys to do homework on what you actually like, because AI field is very big. You need to focus on all the things, at least on a base level, but be the specialized person on one of the categories. So please do that. Yes, thank you very much, guys. Sorry about that. Let me create a zip and others can also send the zip on the community. Yes. 12 live. So this is today's topic. KNN logistic pipeline, because I have gave you these things, compress to zip. Done. Give me a second. I am sending you all the things live. Okay, guys, I've sent the zip. Please also someone please put the zip in the group and please work hard, guys. Yes, thank you very much, guys. Thank you very much for the wishes. Wish you the same. And please do work hard. Okay, tell I will not be here all the time and no one will be here from giving you the reality check. Sometimes even when we are depressed, we are not getting the results, we get depressed, we don't get the reality. And if we don't see the reality, we will always live in this illusion and we are behind. I don't want any of my students to be behind in life. And the big part of life is job, earning, and other things. So It is indirectly connected to everything. Okay. Yes. Happy Diwali, guys. Happy Diwali, everyone. Okay. So let's close this session with a smile